Welcome to this special episode of Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, and today I'm talking with Kevin Moyher, Product Manager at Times Microwave Systems. Welcome, Kevin.
Thanks a lot, and I really appreciate the opportunity.
So we often discuss RF cables in military airborne applications, but they're very important in ground vehicles too for military. What applications in the military ground vehicles are RF cables used in?
I think there's just a tremendous number of applications in military vehicles. Radio communication, SATCOM, GPS, data networking, EW systems like jamming, other electronic countermeasures, identification friend or foe. And we also see, a new application for vehicle stopping, high power RF energy to stop a vehicle. So there's, a tremendous number of applications for coaxial cable assemblies.
And so what are some of the challenges for using RF cables in these military ground vehicles and applications?
I'd have to say it's ruggedization, and ruggedization. Just like that old real estate saying. And there's lots of things to ruggedize for. I mean, concerns are for things like crushing of the cable, kinking of the cable, extreme cold, extreme heat, UV resistance, abrasion resistance, moisture ingress, survivability for like hot caustic washdowns. In the case of these vehicles that they had to go through, say, a biological event or something, they have to be washed down with some, pretty harsh chemicals, and they have to survive that. Corrosion resistance is a concern. Exceeding the minimum bend radius of the cable is always a concern. Performance with flexure is a big one. In most cases, RF cables, they're installed and they're static in place for the life of their application. But in ground-based military vehicles, that's just not the case. Sometimes, things are being set up very quickly or ripped down very quickly. Cable assemblies are being coiled, uncoiled. A lot of things are moving around. So that's really important. And I don't know if I mentioned, but connector retention, that's a big one. A cable assembly, RF interconnect is only as good as its weakest link. And that's a lot of times, where that connector is attached to the cable is really, really important. So, lots of different things to ruggedize. In some applications, you're looking to, prioritize, some of those characteristics above others. But ruggedization is by far the challenge in this market.
And so given this harsh environment, what materials and construction techniques are used to make the RF cables that are suitable for this type of military ground vehicles?
Yeah, lots of different things that we do. Probably first thing comes to mind is hybrid outer conductor constructions. With static applications, you can use a conductive tape or a copper sheath type of thing. But, we have to get a lot more imaginative with, the outer conductor. Some of the things that come to mind is flat braids covered by a helical wrap and a round wire braid. So, kind of a hybrid construction, but a construction that's meant to flex, wants to flex, will perform over time with flexure and maintain loss performance, return loss performance. Yeah, I think that's a big one there. Another one is jackets. Two that come to mind in this application are polyurethane. We have a polyurethane. It's a very rugged, abrasion resistant polyurethane. Also happens to be fire retardant. Happens to be low smoke. It's got a very good bend moment. So it creates a very flexible cable. And neoprene. And I mentioned earlier about the biological events. Neoprene is something that will hold up to some of these hot caustic cleaning agents. Flooding agents never hurts. If there is a breach in the cable, moisture to RF is a real problem. So, flooding agents, almost like a silicone-like material under the jacket that, if there is a breach, the water cannot migrate through that cable. Stainless steel connectors, corrosion-resistant platings are also, very important. And armor could be in the form of extra braids, extra jackets, interlocking armor. We even do a thing where we take a spring steel and we wrap it around the cable, as you can imagine, that creates a lot of crush resistance, but also it helps so that the cable cannot be exceeded, bent beyond its minimum bend radius. It helps quite a bit there. And, as I mentioned earlier, connector retention. Sometimes what we do is instead of just using a tinned copper or silver-plated copper outer conductor, we use like a tin or silver-plated copper-clad steel, which, just adds tremendous pull strength to that connector. Yeah, picking the right outer conductor construction, the right jacket, using steel braid wires, possibly putting it through an armor. You just keep on adding these layers of protection and ruggedization to these cables that really that's the type of application they just need it. That's ruggedization.
And so, given all these physical requirements, what are the performance requirements for the RF cables in military ground vehicles? Are there any special requirements?
Well, the things that pop up most often is, IP67, which is, a moisture sealing requirement. IP67 is, 1 meter underwater for 30 minutes. So that's a very, very common requirement. And as I mentioned, connector retention. They're probably the things that are first pop up with these type of applications. But in terms of like an additional requirements, we see these 14 requirements where basically you're looking for even a greater level of protection against moisture ingress, maybe 2 meters, 3 meters submersion for longer lengths of time. So these vehicles can ford streams, rivers, ponds, that type of thing with a level of confidence that the RFS cable assemblies are going to be sealed to that level. And since this is typically not a static application, these cable assemblies over their lifetime, maybe being mated, unmated, coiled, uncoiled, moved, replaced, that type of thing. Markers become very important in this application. Forward markers, aft markers, and the cable assemblies. And because they're being constantly handled and being in tough environments, maybe chemical washdowns, protecting these markers with clear tubing that that print is going to stand up over time is very, very important. Something I was seeing more often now is requirements for moisture ingress with unmated assemblies. So, in the past, we do things with between the cable connector interface and the cable itself to protect against moisture ingress. But if you happen to have to break down a system and it's raining or it's very humid, there's potential to take in moisture through the unmated connector. So we use special dielectrics that have good RF properties, but moisture cannot penetrate through that exposed interface into the cable. We're starting to see requirements for connectors that don't reflect. You don't want to do all that work and camouflage your vehicle and then be given away by a stainless steel connector or nickel plated connector, that type of thing. So we're doing things like flat black platings to, combined with black boots and black over boots and that type of thing, so that we're not being you're not seeing a reflection in the sunlight, that type of thing.
And so, what are some of the different types of RF cables that are available for military ground vehicles?
Yeah, we have this extensive line of cables, but one that really comes to mind is we call it a T-comp cable, but it's a foamed cable, foam polyethylene cable. But as I mentioned earlier about this hybrid type of outer conductor construction, it has a hybrid outer conductor construction. So it can flex and continue to flex and perform well. A real thin, rugged polyurethane jacket, fire retardant, flexible, abrasion, chemical resistant, and that flooding agent underneath the jacket. So it checks off a lot of boxes. But then we have, some constructions that are designed to extreme flexing, in terms of composite semiconductors that aren't going to work hard and over time. High temperature requirements. I think a little while back during the Afghan war and the war in Iraq, jammers on military vehicles was a big requirement. And I think, we worked with 3 different companies. I think we supplied the bulk of those assemblies, or if not all those assemblies, to that requirement. And each one of those companies had a little different requirements. One was armor. They stressed armor. One of them stressed, abrasion resistance and flexibility and performance with flexure. And the third one stressed high temperature. they're routing these, part of these assemblies are routing through engine compartments. And you think engine compartment of a vehicle out in the desert, just, some pretty high temperatures. So we went to fluoropolymers for the high temperature requirement. So, fluoropolymer cables can come into play as well. And sometimes too, some of these applications are higher frequency, and we have, special constructions. They embrace some of the other characteristics in terms of, ability to perform with flexure over time, and UV resistance, and temperatures, and those type of things, but also have a high frequency performance up around 26 gigahertz and that type of thing.
Well, thank you very much, Kevin, for talking with me today about RF cables used in military ground vehicles. I can see they have to be able to withstand very harsh environments, so that's a good thing. To our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.